Okay, so we're going to talk about synthetic division. So synthetic division is very similar to long division, but it's a lot quicker. It's a lot shorter of a process. So we're going to take the coefficients of the numbers in front. So technically in front of this x to the fourth, we've got a 1. So we're going to put a 1. And then we go in descending order. So we have an x to the fourth. We should have an x to the third, right? So really we have plus here 0x to the third because it's not there. So we have a coefficient of 0. And then we've got a coefficient of negative 10 with our x squared, a negative 2 with our x, and then a 4. We're going to take the opposite of what we are trying to divide by. So that's a positive 3 there, so we're going to do negative 3 for our synthetic division. We drop down the first term. We're going to multiply that term that we drop down by the negative 3, so we get negative 3. And then we add from there. So 0 plus negative 3 gives us negative 3. Negative 3 times negative 3 gives us 9, and then again we add, so negative 10 plus 9 gives us negative 1. Negative 3 times negative 1 gives us 3, which gives us a positive 1 when we add 3 to negative 2, and then negative 3 times 1 gives us a negative 3, and we get a remainder of 1. So if it was a 0 of this function, we would have gotten a 0 there and not a 1. So what that means is we can rewrite x to the fourth minus 10x squared minus 2x plus 4 as x plus 4 times x to the third minus 3x squared minus x plus x plus a remainder of 1 over x plus 3. Okay, so that's all we did. That was synthetic division. Again, just like long division, but a little bit easier, right? A little bit quicker. So let's check out the next one here. So I'm going to put a 5 on the outside of my box. 3, 2, 1, 0. My powers go down perfectly, so I don't have to put a 0 in anywhere. So I got 3, negative 17, 15, and negative 25. Drop down the 3, get a 3. 3 times 5 is 15. 15 plus negative 17 is negative 2. 5 times negative 2 is negative 10. Negative 10 plus 15 gives us 5. 5 times 5 gives us a positive 25. We get a 0, which means this was indeed a factor of the original. So again, we could rewrite this as x minus 5 times 3x squared minus 2x plus 5. And in the next class, we're going to discuss how we take that and then use that to define the zeros of this particular function. But for right now, we're just going to stop there. Last example is a little bit longer, but again, I first check my powers. They go in descending order, 4, 3, 2, 1, and 18, so I don't have to add a 0 this time. I'm going to put a 2 on the outside. And then I'm going to put my coefficients. So I've got 2, 7, negative 4, negative 27, and negative 18. Drop down the 2. 2 times 2 is 4. 4 plus 7 is 11. 2 times 11 is 22. 22 plus a negative 4 is 18. 2 times 18 is 36. 36 minus 27 is 9, and 2 times 9 gives us 18, so we get a 0 there. And this question asks us to take a step further and divide by x plus 3 as well. So I'm going to take the coefficients that I just got when or the quotient, sorry, that I just got from dividing, and I'm going to pull that down. And I'm going to do synthetic division for negative 3. So we get 2 times negative 3, which gives us negative 6. So negative 6 plus 11 gives us 5. Negative 3 times 5 gives us negative 15. So we get a positive 3 there. Negative 3 times 3 gives us a 9. and it's negative, so we get another 0. So what that means is we could rewrite this as x minus 2, x plus 3. Remember, because they're always opposite in sign. And then here on this last step, we've got 2x squared plus 5x plus 3. And then again, we could take that and factor that to find all of the real zeros of functions, which is what we're going to get into next class or on the next video that you watch. If you have any questions, please see me in class.